Hi there, this is Mrs. Hodge. I am going to attempt to do our problem here that deals with confidence intervals for one sample mean. This is the problem that is posted in Schoology. You are supposed to do all 4 parts and then use a calculator to figure that out. I wanted to walk you through that process and what you need to do to turn that in. Okay, so a student surveyed students at a small school in the Northeast U.S. and asked, among other things, how much they had slept the previous night. Here's the data collected from 25 of the students selected at random from the survey. And there's 25 pieces of data here. Now, from that, I then went to do a menu 411. I did a one variable statistic on that, and I found out that the X bar, Y bar of the data is 6.64, and the standard deviation is 1.075 hours. And we're supposed to construct a 90% confidence interval for the mean number of sleep hours. All right, so step 1, parameter. Mu is our parameter, and mu is the true mean true mean of hours slept previous night. All right, if you can kind of see that. All right, assumptions. Let's see, random. It says so randomization. So sample was collected randomly. Independent. Hours slept is independent. Let's see, normal condition. Normal. All right, so there's 3 different ways to do that. So you could have, it's told to you that it's normal, which is not. N is greater than 30, which it's not. Or we can take a look at the data. All right, so let's take a look at the data. So here on my calculator here, I have all the data entered. I'm going to see if I can go and look at my data here. You have to name your, when you go to put your data into the calculator here, don't forget to name your variable up on the top. So then I'm going to click on my data here. I'm going to click my variable, and there is my data. I'm going to change the property. I'm going to plot type. I'm going to make it into a histogram so I can mess with it and see if I can make that somewhat approximately normal. So this is slightly skewed. I'm going to click on one of these bins here. Click on it, hold down. So I have the little closed hand there. I'm going to kind of move. There we go. So that's good. All right, so that is the drawing that I'm going to do. So my drawing that I sketch here, I have 3.5 here. There's a bar that goes to 3. There is a bar that goes to 8. Another bar that goes to 8. And a bar that goes to 6. Okay, I'm going to put another variable down here. This is 8.5. And this is 6.5. All right, so there's my thing. So then I have to write that the distribution is unimodal, symmetric, and approximately normal. Okay, so that's the hard part on my assumptions. Then I have my 10% rule. Let's see if I can squish my paper over a bit. Let me put 10% rule. So 10%, we assume that the population is at least, let's see, our sample was 25 times 10 is 250 people. Conditions have been met. Okay, so somewhere on my work I got all of that in. So let me pull that over again. So again, so you can see it all. There's my conditions. All right, my calculation, I am going to do a T or a Z. This, let's see, do I have the mean and standard deviation of the original population? No, I don't. So I have to do a T interval. I'm doing a T interval, so the formula for that is X bar plus or minus T star and then S over the square root of N. That's all times there. Yeah, you can kind of see that. All right, so now in my substitution here, my X bar was given as 6.64. I'm going to need to look up my 90% confidence for a T. So here's my T chart. This is posted in Schoology. I'm going to go to 90 and look up 25. So 1.708. Y'all see that? So wait, that is a degree of freedom of 20. Degrees of freedom is 24, so my bad. It's 1.711. So the degree of freedom, my D of F, is 24. It's N minus 1. So since there's 25 pieces of data, subtract 1, you get 24. So again, when I go to look up, I go to my 90%, I go to 24 is 1.711. So 1.711 is my critical value. Standard deviation is 1.075. And the square root of N is 25 square rooted, which is 5. Okay, so there's my substitution. Now, let's go back to my calculator here. And there's two ways technically to do this problem. I could do the test from here, from my list and spreadsheet. If I do it from my list and spreadsheet, the way that I would do that is menu, then statistics, which is 4, and then I'm doing a confidence interval, which is 3, and I'm doing a 2 interval, which is 2, and I have my data. I have data, and I cursor down to OK. And my list is A, that's where it's put. The frequency list is 1. I got to change that confidence level to, say, 90, not 95. So I'm going to put it as 0.9. And I want my answer to be input in B. So there's my answer. My lower bound, my upper bound, and I have that. Now, the other way to do that, let me go and switch to my different page. I would do this in the calculator. And then in here, I would do a menu 6, confidence interval is 6, and then again I would do a T interval, and then I wouldn't have data. I would do it as a stat instead, and then I would have my answers here. Since we already know from the problem, it's 6.64 is my X bar, my standard deviation is 1.075, and N is 25, and my confidence is 0.9, and then I again get the same exact answers, but using a different method. At least they should be the same answers there. All right, so there we go. All right, so I have my two answers. I'm going to write those down, rounding to the third decimal place, 6.272 and 7.008. There's my two answers. So I have 3 parts for my calculations. And then lastly, we are 90% confident that the true mean what? True mean hours of sleep. Remember, I'm copying down my parameter, how I defined it. Previous night is between 6.272 and 7.008. All right, well, I hope that helps. If you have any questions, don't forget there's a synchronous part of the course that you can go and take a look at. And hopefully this video didn't record sideways. If it did, hopefully you can open it with your phone and look at it sideways. And good luck.